So Systems That Learn is a new initiative in CSAIL. They're bringing together companies that are excited about the intersection between machine learning and kind of intelligent system design, and sort of the low-level aspects like hardware and software, and how do you design really efficient systems that couple with these machine learning tools. Yeah. I mean, the vision is to bring companies into our department and have them present to us with challenges that they're facing in this sort of big data machine learning space that really involve both how do you navigate the deluge of information that's coming in. So my interest would be aligned with sort of the deluge of information that come from cameras and 3D sensors and depth sensors and all of these sort of objects. How do you manage it in an efficient way? And that's everything from storage to navigation to search. And then how do you do intelligent information, or rather intelligent inference on the information to come up with observations about the world that you might not have seen before. So for example, our group, one of the really interesting challenges and themes that we found is a lot of the algorithms and ideas we've invented for understanding geometry and shape also apply to understanding networks, right? And so this comes up not just in supply chain, but also in understanding things like social networks, right? What is the distance between different people and different groups of people and so on. And so this is an interesting example of this Systems That Learn theme, right? Because if you look at websites like Facebook, Instagram, whatever, just navigating the amount of information that they have and they've collected is already a very large systems challenge. And now there are people like me with a more theoretical background that are coming in with all of these exciting ideas and mathematical constructions for how can I navigate this and do intelligent inference and understanding of this data. But it's not enough to just come up with a model. Now we have to come up with algorithms, systems, and even sometimes hardware that are specifically designed to deal with this kind of modality. Right now I have a lot of students that work quite closely with Adobe Research would be a great example of a partnership in our research group. So obviously Adobe is very interested in manufacturing software like Photoshop, Illustrator, what have you, and the tools that we're coming up with are a good way to help them incorporate sort of more intelligent processing of input from artists and designers, right? So I have a student that's currently working at Adobe on how do you come up with intelligent 3D modeling tools, right? In this case, this idea of generative modeling, right? So I have, can the computer treat a 3D object kind of like a piece of clay for an artist? Can we come up with a computational process that intelligently can understand, like, oh, it looks like you're starting to make a table. Maybe here are different ideas you could come up with different types of legs for your table, or a different surface, or a different, accoutrement around the outside. And in each of these cases, typically the type of cycle that you would need to design any one of those ideas is so ridiculously long that it requires a specialist and somebody that's been trained for many years in software, in design, in artistry. And we're trying to democratize that, right? Bring that to end users at home that maybe don't have that experience but have a good intuition for what they want. And this is only going to become more important, right? 3D printers are a great example of a technology that is going to allow you to take objects that you're coming up with and designing digitally and actually physically realize them, potentially in your own home. But many of the people that have a 3D printer at home very quickly realize that it's not the 3D printer that's the problem, it's coming up with content to go into the 3D printer, right? And because this software is so difficult to use and such a challenge and requires so much specialized knowledge, essentially your 3D printer becomes just a funny version of Amazon.com, right? It's just another way to get somebody else's object they've designed into your home. Right? So the real vision that we have is how can you have people intuitively customize things the same way that really we're seeing a revolution in photography right now, right? That it used to be to come with really high quality photographs was something that a professional did, but now even on your phone, maybe you don't have the same level of artistry, but you can do a pretty reasonable job. That's not the case for 3D and geometric content, for sure. I used to work at Pixar Research, which is sort of a small organization within Pixar. That's a great place to gain perspective on the computer graphics industry, for sure. I mean, what better place, really? One of the really exciting things about working at Pixar Research is essentially you're in the office and artists would come in with an effect or an idea of a scene they're trying to design, and they come to you to come up with the technical tools for how to realize that in an animated feature, right? And so we studied everything from rendering problems, like how do you design and draw a scene in a different way depending on how you achieve a particular look, to very surprisingly low-level physics and number crunching problems. So for instance, my very first job at Pixar was working on their cloth simulation pipeline, right? And so if you watch Ratatouille, you see, the characters running around the kitchen in these different smocks that are, swishing around in the wind. And that doesn't happen by accident, right? And in this case, it's a really interesting sort of intersection between the physical world and the animated world, right? We want to simulate physical dynamics, and we certainly don't want an artist to have to animate every wrinkle and motion of a piece of cloth. But at the same time, they want enough control to get the look that they want. So this is really, it was an interesting place for me to start with my background, because obviously the focus in that world is very different, right? The focus in the computer graphics world and simulation isn't necessarily to get good physics, right? It's to get a nice look. But in exchange for that, some of the creative process that those folks have come up with has led to huge developments in the world of physical simulation, partial differential equations, and so on, in the much more serious disciplines of computer-aided engineering, right? So indeed, some of the really big developments in things like fluid simulation, wind simulation, cloth, and so on have originated in the computer graphics world and now are feeding back into people that people's pipelines for designing cars and making household objects and so on. But it's the same physics, and sort of both sides have something to tell for the story.